Example 6, find the antiderivative of the square root of 2x minus 1 with respect to x. Notice 2x minus 1 shoved inside of a square root function. That's a composite function. Dead giveaway for integration by substitution. What should our u be? Well, we have perhaps an obvious choice of the 2x minus 1 because it's inside of another function. U is equal to 2x minus 1. I think that I'm going to run into a slight issue on this one. Let's see. Take its derivative. Du will be equal to just 2 dx. And you can see that the issue that we have is the lack of a 2. It's not that big of an issue. Just put it in there anyway, and then compensate with a 1/2 on the outside, and then rewrite your integral. So this is 1/2 definite integral, indefinite integral, I should say. So take this 2 with the dx. The 2 with the dx becomes your du. And then the square root of 2x minus 1 becomes the square root of u. And of course, when we're doing our integrals, we don't usually keep the square root in there. We're going to turn it into a rational exponent. 1/2 integral u to the 1/2 du. All right, well, let's use our power rule. This 1/2 sticks around, comes along for the ride. U to the 3/2 divided by 3/2, but we usually just multiply that by 2/3. Plus c. Cancellation. Crayon. Cancel your 2's. Rewrite stuff. We got 1/3 u to the 3/2 plus c. U's are not going to cut it. Take the u out, replace it with a 2x minus 1, and we have 1/3 quantity 2x minus 1 to the 3/2 power plus c. Yeah. Okay. And then, you want to verify it? Sure, we'll do that. If you were to leapfrog this power down, taking the derivative, you'd have 1/3 times your 3/2 multiplied times 2x minus 1. Subtract 1 from that exponent, you'd have 1/2. It is a composite function, so take the derivative of the interior. It would be just 2. And look at all the stuff that gets to cancel. These 3's cancel. This 2 with this 2 cancels. And then we're left with 2x minus 1 to the 1/2, which is what we started with. Hooray! All right, so we're going to do this game again. Here's the example we just did. What's the difference between this one and the next one? What the heck? They threw an x on the outside. So remember, we can fix a constant like a 2. What are we supposed to do whenever there's a function on the outside here that's not really part of this interior's derivative? Okay, well, let's see what we're supposed to do, shall we? Okay, let's just follow the same exact procedure that we did before. We would think that we're going to use, 2x minus 1 as our interior function, right? Okay, and then take its derivative. Du is equal to 2 dx. All right, so far, what I do need to fix is the fact that there's no 2 in here. All right, so we'll fix that. So we'll put a 2 here. We'll put a 1/2 on the outside, so we fixed that. What we haven't fixed yet is an x. So I can't fix that the same way that I fixed the constant. You can't just pull out an x. Constants get to come out like the 2 gets to come out, but x's functions do not, right? Because it's some sort of function that you're finding. Let's say if I put it in the context of definite integration, you're finding the area underneath the curve, and that thing is changing. It's changing because it's an x. When it's a 2, it's not changing. It stays some constant value. All right? Okay. So if only we had a function. So we're trying to rewrite this, right? We're rewriting it in terms of u. If only we had a function that related our u's to our x's. Man, if only we did. Wait a minute, don't we? I think we do. It's just right there. This function relates the u's and the x's. So what I can do is I can solve this equation for x, and I'm going to get something in terms of u that I can substitute in here. That's what I'm going to do. And maybe I do that in another color. Why not? So I'd have to add over the 1. I have u plus 1 is equal to 2x divide by 2, and I get x is equal to a u plus 1 over a 2. Now I have everything that I need for my substitution process. So you get to kind of think of this as like a double substitution. All right, now when I'm rewriting this 1/2 on the outside, of course, is going to stick around, integral. This 2 with the dx becomes the du. Put that right here at the end. The x is u plus 1 over 2. Okay, and then the square root of 2x minus 1 is going to become the square root of u. And of course, I already know from the last one, I'm going to rewrite that as u to the 1/2. All right, you're looking at this and you're going, yeah, but I just turned this into a product of something, and I don't have an integration rule for a product. But before you start, peeing your pants and stuff, understand that, hey, this one is easy to fix. The reason why it's easy to fix is because the square root is on the u, and you could distribute that through the parentheses. You can't do that with this thing in here. You can't take this x and distribute it through the square root, but you can do the reverse. Before I do that, I'm going to go ahead and take this 2 outside to meet this 2, make that thing a 1/4 integral of, and now let's distribute this guy, boop, boop, make that u to the 3/2, I think, and then plus u to the 1/2 du. Man, there is no way this is going to work. All right, I don't know. Let's just keep going with it. Let's see where it leads. Keep the 1/4 on the outside of this. And now individually take the antiderivative of each of these u's. So this would be u to the 5/2 divided by 5/2, or, alternatively multiply it by 2/5, plus u to the 3/2 times 2/3. I'm not satisfied with that. I'm also not satisfied with that plus sign. There we go. And then plus our c here. Okay, back substitution. And you know what? What we can also do, let's just go ahead and distribute the 1/4 through that. I'm going to do that before I back substitute. You could do it at the same time if you wanted. So when I multiply the 1/4 times the 2/5, a factor of 2 here and a factor of 2 will cancel out. So I'll actually have 1/10. Don't write with the laser. And I'll make that a 2x minus 1 to the, so it turns out I'm going to do them both at the same time. All right, anyway, again, a 2 here is going to cancel out with a 2 here, leaving a 2 times 3, 1/6, plus 1/6, 2x minus 1 to the 3/2, and then plus c. How confident are you about this? There's no way. How is that, when you take its derivative, it's supposed to simplify down to this? I'm not convinced. So there's only one thing left to do. Take the derivative and let's see. So when we take the derivative of this, 1/10, leapfrog our power down, 5/2 multiplied times 2x minus 1, or subtract 1 from the x1, so 3/2, yeah. Multiply times the derivative of the interior, 2, right? Bring down the 1/6 from the other one, leapfrog the power of, what, 3/2 down? 2x minus 1, subtract 1 from the exponent, half, yep. And let's see, multiply it times derivative of the interior, 2. All right, that's good. All right, let's see if we can clean this thing up. So far, not so good. Jeez. All right, so cancellation crayon this time is going to be green, whatever. So 5 and 10 gives us a 2. Maybe one of these 2's, and this 2 cancels out, but I still have this 2 that's right there. I have a half, square root of 2x minus 1 to the 3/2. Okay, all right, so those cancellation crayon again. This one with this one. Yeah, that's going to cancel out, and leaving a 2 there. One of these 2's cancels out with one of those 2. I got another half there. What do you know? Oh, no, wrong color. Come on, keep it consistent. 1/2, 2x minus 1 to the 1/2. I don't know. Well, can we factor this? Here, let's try to factor it. There is a common factor. We have a 1/2 common to both of them, and then we have a factor of 2x minus 1 common to both of them. And remember that when you're doing this fancy factoring technique, you always take out the lowest power, which is going to be to the 1/2. Okay. So let's pull out this 1/2. 2x minus 1 to the 1/2 power. Open the brackets here. And just basically divide this. So think of this as something to the 3/2 power divided by that same something to the 1/2 power. Like bases, you just subtract the exponents. That is going to be that something to the 2/2, which is 1. Oh, no, that's the correct color. So it's a 2x minus 1 left there, right? So again, if you were to multiply this times this, you would add the exponents. It would be 1 plus 1/2, which is our 3/2. That's there. All right, glorious. And then plus, well, this is exactly what I just factored out, right? So that's just going to be a 1. What do you know about that? I think we're getting somewhere. All right, let's see. Let's clean this guy right up here. I can get rid of the parentheses because they serve no function. And then I can cancel out with my green crayon these. And then I can also cancel out this 2 and this 2 here. And then I can rewrite my final answer as, bring this x out front, rewrite that 1/2 power as the square root of 2x minus 1. And there you have it.